So the first is, and this should not be new to you at Dow. Digitization is basically transforming the economy, right? What we've seen over the last 30 years has been this relentless use of computation in business, starting in the 60s and 70s with mainframes, and then increasingly more and more workers got access to computation and at lower and lower costs, to now where everybody has access to basically high-speed computing. So, there's about 6 billion people in the world and 4.5 billion mobile phones, right? Smartphones that are out there already. So if you just think about the computation power that's in the hands of everybody, and just imagine all the different elements of your life that have already been digitized, you can see that this relentless march of technology continues in our society, in our business culture as well. And what we see happening is that as the different eras of technology have evolved, they've also evolved different economic architectures as well, with different firms owning sort of almost monopoly positions in these settings. So, in the mainframe era, we were all about products and selling products. And IBM and digital were sort of the rulers. Then in the world of PC and web, we saw the rise of ecosystems and Microsoft and Yahoo and eBay. And then, in the world of mobile and cloud, we see Google and Facebook emerge as the power. And here, what you start to see is that the business model of these companies also started to change. These companies decided not to charge customers for their use of their products, but in fact found other people who would subsidize the customer's use, which was basically advertisers. And then in the world of networks and AI, we see basically large hubs emerge inside of the economy, through which lots of transactions undertake themselves. I just saw this news yesterday that Ford announced, right, that they're going to basically standardize everything on the Google Android operating system for their cars. That's a pretty big news, right? If you sort of think about them basically giving Google access to the controls of the car, all the data in the car, and so forth, it tells you that now Google is going to be already through Waymo. They're doing some interesting things in the auto industry, but now with Ford, right, they're going to be a linchpin now in this industry, with them being a giant hub. And so this is what the economy is that we're living in. And what we see is that there's a ton of sort of hype around AI. You can sort of see all the headlines sort of show up. And the thing to sort of think about first is whenever you see hype around a particular topic, or whenever you see sort of lots of companies entering a space, lots of startups emerging, you should be asking yourselves sort of two perspectives. One is, has the cost of entry dropped, right? Has the cost of entry dropped? And what we see happening, of course, is that for AI, the cost to innovate have dropped radically. And I'll show you some examples of that. The second is, do people see opportunity, right? Do people see opportunity? And the answer with AI is yes. All these headlines tell us that basically both with the cost of entry dropping and people seeing lots of opportunity, you see a ton of entry, a ton of people trying to make sense of it and trying to, improve both their existing businesses, but also create new businesses. Let me add one more bit, which is, COVID, right? COVID has also driven a ton of digital acceleration on top as well. So all of these things are sort of working, in concert to drive this hype. And just to get ourselves on the same page, when people think about AI, most of their thoughts go to what's known as strong AI. This is the AI in Star Wars and Star Trek and the Expanse series, right? Fully autonomous AI systems that can think and act on their own, right? Where their actions are autonomous and it matches or surpasses human intelligence. That's known as strong AI. We're not there yet in that world. What we're living in is what's known as weak AI in computer science, which is any activities computers are able to perform that humans once performed. In this case, the question becomes, well, how good is the performance? and how accurate is the performance, and where is this performance being done. So in weak AI, what you have are very specific dedicated algorithms that do one thing and just one thing alone. It might paint a picture that's in the style of the Rembrandt, right? But that's all it will do. And when that happens, we're then basically able to then take that one particular portion, paint the Rembrandt over and over again. If we're going to paint it to Renoir, we'd need more different algorithms for Renoir and a different one for Da Vinci. But the point is that you can have lots of these algorithms working at scale in an enterprise and doing amazing things. Romain is asking a very good question, which is that as more and more information becomes available, could we see a reduction in the bullwhip effect and less volatility? I think in theory, I think that's true, but I think what drives the bullwhip effect, and Courtney, you'll probably remember the beer game that we played in TOM. What drives the bullwhip effect is actually sort of how information is being processed by different people. And so if you have heterogeneity in algorithms and algorithmic processing of information, then I would say that the bullwhip effect will still exist, and there'll potentially still be volatility in the commodities marketplace. Greg's also asking a good question, which is, would it be fair to just call it a weak AI, just a program? I think what I would sort of say is that weak AI is a program in the sense that these are machine learning algorithms that do very specific things, and we'll walk through the details. They're encapsulated in a software program, of course, but underneath it is a self-learning algorithm, and we'll walk through what that means. And then Ahmad is also asking, do we need 5G before strong AI becomes reality? No, I don't think 5G. 5G is more of a communications and data access story. I think strong AI is more about the advancements in computer science and algorithmic development to basically sort of have a pretty singularity type of an event where machines sort of gain consciousness. I don't think we're there yet, but the advances in quantum computing may push us there. But the point I want to make is this weak AI setup is what is driving much of the hype, much of the advances today that we see in the economy around AI. And one of my favorite examples comes from China, and I'll give you another China example as well soon. But this example is very interesting. So JD Digits, which is a financial services spinoff of JD.com, sort of Chinese, eBay basically. They were asked by the Chinese government to enter the market and offer insurance services and financial services to farmers. So they go out there, they do a large survey of various different types of opportunities for finance in China for farmers. And what they realize is that there's a pretty large footprint of pig farmers in China. And they go, oh, we should offer them insurance, because they realize that pig farmers are underinsured. And very quickly they ran into a problem, because in order for them to be able to offer insurance to pig farmers, they would need hundreds of thousands of people to go around, count all the pigs, uniquely identify each pig, right? And then figure out how much insurance the farmer wants on the herd of pigs, right? And so you can imagine this would be a very labor intensive process. What they did instead is, like, we're not going to put people at this. We're actually going to put technology at this. So they took off-the-shelf algorithms for facial detection for humans, modified them to then do facial detection for pigs. So then they could uniquely identify pigs. Apparently that can be done, right? And then they could accurately see which pigs have actually been insured. But then using the same technology of image recognition, they said, oh, we can start to keep track of pigs. We can keep track of what they're eating, how healthy they are, their weight, right, when they're ready for becoming bacon. And we can, in fact, start to create a whole range of marketplaces that enable the pig farmer to access insurance, access feed and farm supplies, and also the back end of their market for the slaughterhouses. All of that, right, is enabled because of their investment in the AI. It's a very different operating model for a company like this versus a traditional insurance company. They're not going to go to market selling, pig facial recognition software, right? But they're going to use that technology, right, to go out there and completely re-engineer their business, completely rethink what an insurance company does with farmers. And that's sort of the use of weak AI, right? You take one algorithm that's good at one thing and then find other use cases and start to expand the footprint within which these guys operate. Another example of this, again, to sort of show you how accessible this is comes from our lab. We do a lot of crowdsourcing work. And part of my entry into AI was we were doing a range of crowdsourcing challenges for NASA, for Harvard Medical School, and so forth, in the software and the computation space. And the code we started to see emerge in the 2010s, 11s, 12s, and 13s was all sort of at that stage leading edge machine learning. So in this case, a few years ago, we worked with our colleagues at the medical school and at Harvard hospitals, and they had a very simple question. Right now, it's very labor intensive for radiation oncologists to outline tumors for radiation therapy planning. For example, in lung cancer, right? If somebody has lung cancer, then a radiation oncologist has to sit there and outline every single tumor in a 3D space. Right. And sometimes this can be in the hundreds, and it can take you, hours, if not days, to do this properly. They were wondering if we could actually solve this problem through AI. So we ran an open challenge to the world. We said, we have a data set, right? Help us create algorithms that can actually do this job. And what we discovered after 8 weeks and $80,000 spending money, prize money, that our solution could be as good as the average Harvard-trained radiation oncologist, right, in outlining tumors, right? So all of a sudden, the workflow and how you'd organize a radiation oncology clinic has been completely turned around. You no longer need to take the most scarce resource, which is a radiation oncologist, and put them on this task. These systems can be as good, if not better, than radiation oncologists, and they don't suffer from I had a fight with my spouse yesterday, so then I'm not going to be a good outliner of tumors, right? You see there's all the human biases that come in, and these machines are consistent and can accurately give us the solutions. Now, the thing to note here is that we had a great publication. This came out. And we've been very happy with the pickup of this, and the code is being used in a bunch of settings. But I'm a co-author in this paper. The last time I took biology was in 10th grade, right? And I got a C, right? And so I went back into biology. And here I am publishing the leading cancer journal talking about AI applications in life sciences. Again, my claim is that the cost to innovate with AI in almost any domain has dropped radically, and this enables us to actually go out there and figure out, how to start deploying it in our particular context. So first, let me just sort of start with a wake-up call, just to contextualize why people feel an urgency. I'm sure if I asked you folks how many of you have had a Nokia phone, most of you would have raised your hands. This was the headline and the cover story in Forbes in 2007 in November. Nokia, 1 billion customers. Can anyone catch the cell phone king? Of course, the answer is yes. And in the consumer cell phone market, they are in many ways irrelevant. And there's many explanations for their demise. Apple iPhone is sort of viewed as the main culprit, introduced basically around the same time. Had internet access, apps, camera, touchscreen, maps, music, right? But look at all the following first by Nokia as well. They were the first phone with a web browser. They were the first smartphone with third-party apps. They were second in offering a camera on their phone. A first phone with a touchscreen, right? And by 2007, the dawn of the rise of Apple, they already had an app store, they had digital maps, and their smartphone market share was 67%. So it's remarkable, right? How they went from this massive position to nothing. And in case you're wondering, well, maybe they stopped, investing in R&D. Maybe they weren't doing, innovation. They were spending 5 billion euros per year on R&D, close to 10% of revenue on R&D in the period in which they were basically dying when competing against Nokia. So they have both invented all the technologies that Apple used, were investing in R&D, and yet they still disappeared. Right? It's a weird situation. And you can see it, right? Like, you see what's going on, right? So they had every single phone. They had a smartphone for music, a navigator phone for maps, communicator with apps. All of these things were there. What we sort of see happening is that basically you had two very different systems work together. Nokia had a traditional operating model, which over time was highly siloed. Each of these products had their own engineering teams, their own software teams, their own data teams, their own marketing teams. And so you can imagine all that money was being spread across all these different products. And so as the number of users increased, they couldn't raise the value per user. And Apple came in with this digital operating model and really basically collided with them in a way that enabled them to have one platform and grow at an exponential rate. And when this happens, what we see is that there is a shift in industry structure. Nokia died, Motorola died, Sony Ericsson died at the same time. And all the heterogeneity in products that we saw in the phone business basically went over to the platform. And all the phones are the same. All the heterogeneity is actually now in the apps. It's in the software. And what we see, the explanation for this is very important for us to figure out. So I'm going to give you, as a Harvard professor, I always have to give a 2x2. So this is sort of my 2x2 to help you. What we have on this 2x2, this is from colleagues from Harvard, Kim Clark and Rebecca Henderson. They have this notion of architectural innovation. And what they think about when they think about technologies, products, or services, they think about it in terms of the components that comprise the product and service, and then the connection between the components, the architecture. And the components could be new, right? Or the architecture could be new. So if you sort of think about the first cell phone, it was a radical innovation because you had new components. You had antennas, batteries, base stations, digital displays, right? So you had new components and you had a new architecture, like new connections amongst the components. If you think about iPhones 2, 3, 4, 5, 6, right? Those were pretty much same components and same architecture. When you think about new components with the same architecture, you can think of that as modular innovation, right? So Touch ID and Face ID basically swapped out our number punching system on the phones. The first iPhone, though, was it was known as an architectural innovation, where they took existing component and re-architected them in a way so that it ended up creating the iPhone, right? And the iPhone was interesting because the concept of apps was there, the concept of music and maps and email and integration was always there. Apple just put it to touch screens, right? Apple just put it together in a new package, but they also rethought their operating model because what they realized was that how they went to market was not going to be based on the apps they developed, right? It was going to be on the apps other people developed. And the revenue model was going to be as much of selling hardware as much as it was making commission from the apps being sold in their system. So the architectural innovation was both in terms of the technology, but also their business model as well and their operating model. And the issue with an architectural innovation is that that it's really hard to recognize by industry incumbents, right? And this type of architectural shifts, basically, management teams have a hard time recognizing, And when they do recognize it, what they find is that they have to then change their organization to respond, and org change is very difficult, right? In many ways, the architecture of the product or service mirrors the architecture of your organization. And if all of a sudden your architecture is going to change for your product, then your organizational architecture also has to change, and this becomes very, very difficult. Carlos had this question about, if a company stays out of platform or ecosystem, is it doomed to fail? I don't think you're doomed to fail. I think Carlos, the real question is, many of your customers, much of your supply chain may already be on platforms, right? And so even if you don't build your own platform, you have to learn how to participate in other people's platforms, because expectations of that amongst customers has just greatly increased, right? Right? Who would have imagined that all the restaurants would now be on Uber Eats, for example, right? And that the menus would be digitized. You remember your restaurant experience pre-pandemic, right? PDF files for menus. You can't even tell the menus. It's really hard to know what's going on. And all of a sudden, within months, all of that changed. So my view is that that having a platform strategy is going to be essential for all companies, regardless of what business you're in. And we'll talk about that. And the platform strategy will also mean having an AI strategy, because they fit together. Carlos Ruiz is saying, are companies effectively using crowdsourcing to innovate and lead? We can talk. I can send you books on that. There's a lot of work shown with NASA or with Pfizer or even P&G, with the use of crowdsourcing to innovate rapidly, and we can have a whole other presentation on that as well. So architectural innovation becomes key, and Nokia was again killed by this collision of two very different firms, right, with different operating architectures, right? Nokia was fully siloed, right, and each silo ran its own thing. Right, and there's no sharing across these silos, no sharing of knowledge, no sharing of customer insights, no sharing of perspectives. Versus the digital operating model, the platform operating model, basically has data at its core, right? Data runs across the entire enterprise, right? And you have one platform with ways to access it as needed, and then the different products basically become apps on top of a common shared core platform. This model of the firm is, again, what has dominated the software business, but is increasingly dominating a whole bunch of other consumer businesses. And as we'll talk about this a bit more, that we're now seeing even in the industrial setting, in the B2B setting, these types of models also come to fruition. We've shared with Courtney a case on Moderna. I'll talk about Moderna as well. And Moderna is basically building a platform for drug discovery. All of us have been lucky that they were ready with an mRNA vaccine, right? And it's a very interesting story. But the other part of this is that they're imagining that they can have lots of other companies work with them to generate other mRNA-based drugs, and they're using them as a platform to figure that out. So again, and this shifts to a platform, all the profits goes to the software layer. All the profits end up going to the platform hub as well. So if you sort of look at a company like Huawei, they're working pretty hard, but very low operating margins. You look at a company like T-Mobile, they're actually in the negative, operating margin growth rates. So you can see how these shifts are so important.